So hello everyone. So today we will discuss about electric dipole. Let us consider two opposite charges, that is one is plus q, one is minus q, but the magnitude are same, so that is q. They are separated in a very small distance 2a. Now in this situation the coupled effect of these two charges are considered as a dipole effect, because that is two pole, one is negative, one is positive, but they are separated by a very small distance. So there will be field due to this dipole, and so we will talk about the effect of this dipole. Moment of this dipole is taken as the magnitude of the charge of any of one that is positive or negative, and also half of the distance in between them. So that is P is equal to Q into A. So now what we will do, we will try to find out the field due to a dipole. First we will start with a simple approach, that is for an axial point, that is there is minus q is there, plus q is there at the same line at some distant point, which is at a distance r from the center of the two charges of the dipole. So if we consider the general form of the electric field, then E is equal to 1 by 4 pi epsilon 0 q divided by r square, where r is the distance of that point where we want to calculate the field. Now in this case we can consider the both of the charges separately. We know that the principle of superposition, that for two charges we can calculate separately and then add up. So for plus q, E plus q will be 1 by 4 pi epsilon 0 q divided by r minus a square. Why r minus a? Because r is the distance from the center. So the charge plus q and the point is at a distance of r minus a, and similarly the charge minus q is at a distance at r plus a. So for this electric field for minus q will be minus 1 by 4 pi epsilon 0 q divided by r plus a whole square. The total electric field will be E plus q plus E minus q. So if we add the two factors plus q and minus q, so the total will be 1 by 4 pi epsilon 0 2 pr divided by r square minus a square whole of square. So here P is the dipole moment, and why we have written in this form, because as we are using it for a dipole, so writing only q will not visualize our things like that. So if we write in the form of P, that is q into a, so this will make sense that it is an expression for the dipole. So this is for an axial point. We can make some assumptions to the equation, that let's take that the length of the dipole is very small, so compared to the distant point, so a is very less than r. In that scenario, that is r square minus a square terms will only become the r square. So we can simplify the previous equation in the form that the total electric field will be 1 by 4 pi epsilon 0 2p divided by r cube. This is a very simplified form. Now let us take a point which is not in that line but in a direction perpendicular to both the plus q and minus q and at the center, so that you can see in the picture. So we can call it as a diagonal point also, and at this point the magnitude of the electric field will be same for the two charges, that is plus q and minus q, so which can be written as 1 by 4 pi epsilon 0 q divided by r square plus a square. Now why r square plus a square? Because we can see that this point makes an right angle triangle with both of the charges, so distance square will be r square plus a square. Now the total electric field will be 2 times, that is the electric field for one charge, to cos theta. Why cos theta? Because the direction of the resultant field will be along this cos theta direction. Now if we can put the value of cos theta, because we know that the angle theta is here, so the cos theta will be a divided by square root of r square plus a square, and thus by replacing we can find the final equation as 1 by 4 pi epsilon 0 is p divided by r square plus a square, and their total power by 3 by 2. Here also we can make some simplification considering the length of the dipole as very small. So in that scenario also we can neglect the term a in the previous equation, and then it will again become 1 by 4 pi epsilon 0 p divided by r cube. In the case of axial point it was 2p, so the value at axial point was double compared to the point at some diagonal point. Until now we are dealing with some special cases, that is some axial point, field at some axial point and field at some diagonal point. So now we will take care of an arbitrary point at some arbitrary point from a distance r from the middle of the dipole. We will try to find out the expression for electric field for this particular dipole at some arbitrary point. To do that, first we will consider the dipole moment, which is p. We can split p as a cos theta part and one sin theta part, and now we can see that for the cos theta part we can assume that there is some value of charges is there, so this is a like axial point, so the point is like axial point to that. And for the sin theta part, the test charge point or the field measurement point is like a diagonal point. We have already derived the expression for the axial and also diagonal points, so we'll use those in this equation, but here p will be p cos theta and p sin theta. So basically we can write E1, that is from the linear part, axial part, and E2, there is their mod values. E2 is for the diagonal part, so they can be written in this form using our previous derivations. Now in these two equations, if we add the total field, then it will be very difficult to calculate, because there is one part is r square minus a square, another is r square plus a square at the denominator, and they have different powers also. So basically for that we can try to simplify the equation, and for that we can assume that the length of the dipole is very small compared to the field point, so that we can take the approximation as r is very greater than the a. So then we will get these two equations for the two fields, for one is parallel, one is perpendicular position, and to add them we can use the Pythagoras theorem. That is, we can see at the field point the total electric field will be at some angle from E1 and E2, but one thing is to consider that E1 and E2 both they are at some 90-degree angle. So we can use the formula like the total electric field will be square root of E1 square plus E2 square. If we put their values, then we will come up with this equation, final equation, that is 1 by 4 pi epsilon 0 p by r cube into 3 cos square theta plus 1. That can be simplified easily, because 4 times cos square theta we can split it into 3 cos square theta plus cos square theta plus sin square theta, and we know that cos square theta plus sin square theta is equal to 1. So this is a general expression for a dipole, so we can find out the electric field at any arbitrary point due to a dipole which is far away, or we can take the length of the dipole as very small. This is small approximation for this. So next is the torque on a dipole. When we place a dipole in a homogeneous electric field, so what will happen, that the dipole will experience some force, angular force, which will try to align the dipole in the direction of the electric field. So this how it will explain some torque. Now the expression for the torque tau will be P cross E, that is a cross product. So if we want to find out the magnitude of the torque, that will be PE times the sine theta. Theta is the angle in between the applied electric field, that is the homogeneous electric field, and the dipole moment. Now when a dipole is in some electric field, homogeneous electric field, it will do some work when it rotates. So some potential energy is stored in the dipole. So how much is it? So U is equal to P dot E, that is a dot product. So it is PE times cos theta. So this is the potential energy for a dipole.
Please hit the like button if you liked it. Share if you feel it can help others. Subscribe to get new videos. Thank you and keep watching.